In this segment, we're going to talk about considerations for evaluative modeling for trade spaces. First, let's return to the design value loop perspective. In this perspective, we have three categories of models that we're going to need to generate our trade space data. The first, cost models, transform our design variables into resource attributes. Second, we have performance models, which transforms our design variables into performance attributes. And lastly, we have our value models, which take our resource attributes and our performance attributes and transform them to measures of satisfaction. Could be, for example, utility. We're going to talk about the first two categories in this segment, evaluative models, which include performance models and cost models. Now, there are many different kinds of evaluative models that one might use. These could include different techniques such as regression models, agent-based simulations, physics-based models, and so forth. One thing that we have to keep in mind is recognizing the impact of model choice itself. It's important to recognize that the particular models that we're using is shaping the insights that we're going to gain. Now, sensitivity analysis is essential, but many studies often neglect this as that happens at the end of a project. Since assumptions impact the results of our models, the choices of model parameters itself is important for determining whether a particular model is sensitive and/or appropriate for a study at hand. One might consider using multiple evaluative models to try to answer the same question in order to understand the impact of the model choice on our insights. Techniques in different fields, such as weather forecasting, uses ensemble modeling, where you get multiple predictive models that are aggregated in some way to understand the sensitivity and uncertainty around the performance outcomes, for example, of different alternatives. Now, the correctness of a particular model may be uncertain. If that's the case, it's very difficult to validate the goodness or the fidelity of particular models in answering a question. Again, using a multiple model-based approach allows us to get insights in terms of the impact of different outcome parameters and how sensitive they are to model choice. If we want to develop resilient decisions, these are decisions that will perform well in spite of uncertainties in terms of which models are best. It's essential that model choice be appropriate and aligned with expectations, resources, available data, and that you're aware of the impact of those models on your decision making. Another thing to keep in mind when picking evaluative models is recognizing the impact that models have on our trust in the outcomes. In particular, it's important to recognize there are two different types of models at play when you're making a decision. We have mental models, that which is in our heads, and we have constructed models, that which is written down. Constructed models, for example, may include computationally based models, such as agent-based models and physics-based models that are run on a computer. Constructed models are explicit, so they're traceable and can be communicated more effectively than mental models. But oftentimes, trust is based on our mental models. The process of gaining trust in a constructed model often entails the comparison of the outputs of constructed models with outputs of our mental models. One of the benefits of evaluative models is that they're often trying to predict objective outcomes. These are outcomes that are based in reality. The bottom line is that our mental models, if they're not compatible with information, we do not trust it. Our mental models may diverge from our constructed models in many ways. It includes not being compatible with one another. Our mental models may not be reflections of reality. Our constructed models may not reflect reality, and our constructed models may not reflect our true values. In order to make decisions based on model-generated data, we need both trust and truthfulness. Now, models to be used for trade space exploration analysis need to be fit for purpose. That is, the appropriate level of sufficient information is truthfulness, which is validated, and trust, possibly done through interaction, for example. Particular models we're going to use for generating trade space data need to be able to take in our design choices and design vectors. These include our design variables and their ranges, along with any modeling assumptions, which we often contain within a constants vector. Our models have a number of outputs. These include our attributes, which are primary measures of value, as well as costs and aggregate performances of benefit. There are various approaches for evaluative modeling. These include techniques such as tabulation, which could be a big lookup table of data. Could include explicit calculation, for example, attributes as a function of our design variables and our constants variables. Or it could be implicit through iterative calculations. At the high end, we have simulation, or time-based approaches for predicting performance and cost. Our value models then take these outputs to aggregate into value metrics. But it's important that the simplest model be used that's necessary for the study at hand. It's very easy to spend too much resources and time on developing high-fidelity models that are providing unnecessarily detailed information that will not result in differentiating value metrics. In practice, what we find is a spiral-based approach is most useful, where we start with very low-fidelity models And as design variables are determined to be impactful on our attributes, we turn up the fidelity in those particular relationships so we have better insight into the relationship between our design variables and our attributes.